Alrighty, so this is Algebra 2, Chapter 11, Section 4. It's called Conditional Probability. And if you could please put notes in your title, that will help me identify what it is I'm grading. Our learning objectives for this section is to find conditional probabilities and to use table and tree diagrams to determine conditional probabilities. So the probability that an event B will occur, given that another event A has already occurred, is called conditional probability. Our essential understanding is conditional probability exists when two events are dependent. You write the conditional probability of event B, given that event A occurs, as P of B given A. You read P parenthesis B line A as the probability of event B given event A. So let's put this here and this. Alright, so finding conditional probability. The table shows students by gender and type of school in 2005. You pick a student at random. A says, what is the probability of being female given that you're in, what's the probability of being in graduate school given, hold on, I'm reading. So the probability of event B given event A. Probability of being female given that you're in graduate school. The condition that the person selected is at graduate school limits the sample space to 3,303,000 graduate students. So your total students in graduate school are these two numbers added together. If we do that, I'm just going to do it in my calculator. 1349 plus 1954 is the 303, and these are in thousands. So I'm going to put 3 zeros onto that, and that's how they get 3,303,000. And then of those, 1,954 are female. So then you go look at your female, and it's 1954. So the probability of being female given that you're in graduate school is 1954 over 3303. And when you calculate that, that's 0.59 or 59%. So let's look at another probability. Just this one isn't conditional. This is just probability of being female. So the probability of female is your total number of females divided by your total number of students. So you have to total your females, which is 2462, 5517, and 1954. And then you're going to divide that by your total number of students, and that is all of these kids. So that's 1866, 2462, 4324, 5517, 1349, and 1954. When you do the math on that, you get 1933 over 17,472, and that's about 57%. All right, now it's our turn. So you guys are actually going to do this problem. So let's look at, in problem 1, what is the probability that you're in a 4-year college and male, given that you're a dude? So we need to total up everybody in a 4-year. if you're in a four-year college, that's all the ladies and all the dudes. So we add those together. 43.24 plus 55.17. That's 98.41. And then we are specifically focusing on males. So there are 4,324 dudes. All right, so let's get that as a decimal. 98.41. So that's 43.9. Oops, that's not a pen. So without calculating, oh, this is fun. Without calculating, let's look at B. Given a student is enrolled in a four-year college, that's these guys in the middle, is it more likely for a student to be male or female slang? Without calculating anything, you're in a four-year college. Is it more likely that you're going to be a male or a female? Female. Because there are more of them. 65.17 is more than 43.24. So without calculating anything, we can evaluate data. How nice is that? All right, so conditional probability. We definitely want to write this down. So for any two events, A and B, and please let the probability be that A, not be 0. The probability of B given A is the probability of A and B divided by the probability of A. So just to expand on this, yesterday we learned that probability of A and B is whatever the probability of A is times whatever the probability of B is. Delay that order. Never mind. All right, so we're going to look at a problem together and then see how this applies to particular problems. So a utility company asked 50 of its customers whether they pay their bills online or by mail. What is the probability that a customer pays the bill online given that the customer is male? So if you look, online mail is 12. So the probability of being male and paying it online is 12 out of 50. The probability of being male is 20 out of 50 because 12 plus 8 is 20 out of 50 altogether. So if we use the formula, you take the probability of being male and online and divide it by the probability of just being male. If you multiply the top and the bottom by 50, you'll get 12 over 20, which is 3 over 5, which is 0.6. So the probability that a customer pays online, given that the customer is male, is 0.6, or 60%. None of that you have to write. So this is our problem. So go ahead and copy down this table. And researchers ask shampoo users whether they apply shampoo directly to the head or indirectly using a hand. Squirt straight from the bottle, or hand and then head. What is the probability that a respondent applies shampoo directly to the head, given that they are female? So if we look at the equation that we're going to use, we're going to find the probability that we are female and apply directly to the head and divide it by the probability of being female. All right, so we need to find out our total number of people. Because we're going to use the heck out of our total people. So we've got 2 plus 6 plus 18 plus 24. And I'm going to do root according to what's convenient. 2 plus 18 is 20. And 6 plus 24 is 30. So we have a total of 50 people. So the probability of applying directly to the head and being female is 6 out of 50. We're going to divide that by the probability of being female, which in this case is 30 out of 50. If I multiply the top and the bottom by 50, I'm good to the top and to the bottom. We get 6 out of 30, which is a 1/5, which is 0.2. So the probability of applying shampoo directly to the head and given that the respondent is female is 0.2. All right, so it follows from the probability of B given A equal to the probability of A and B divided by the probability of A, that the probability of A and B is equal to the probability of A times the probability of B given A. Because you can work your way backwards out of this if you multiply both sides by probability of A. You get this equation. So let's just write this down. You can use this rule along with the tree diagram to find the probabilities of dependent events. So let's look at the sample problem, and then we'll do a problem together. So we're going to use a tree diagram. A school system compiled the following information from a survey it sent to people who were juniors 10 years earlier. 85% of students graduated from high school. Of the students who graduated from high school, 90% are happy with their present jobs. Of the students who did not graduate from high school, 60% are happy with their present jobs. What is the probability that a person from the junior class 10 years ago graduated from high school and is happy with his or her present job? Make a tree diagram to help organize the information. G is equal to graduated, NG is not graduated, H is happy, NH is not happy. So you start with your class, they're right here. And you know 85% graduated, so this branch gets the 0.8. What percent did not graduate? It's the 100 minus the 85. So you have to be a little bit smart on that. You have to know that you start out with 100% of people, and then whoever didn't, the remainder of that 100% gets the not graduated status. So this branch represents the student who did graduate. Each first branch represents a simple probability. And then this bottom branch represents students who did not graduate. Each second branch represents a conditional probability. The probability of happy and graduated, and the probability of not happy, not graduated. So we had 90%. The not happy has to be that other 10%. You have 6% happy here, the other is 40%. Okay, let's do this. The blue highlighted branch, which is this one here, represents the probability of graduated and happy. Using the equation we wrote above, the probability of graduated and happy is the probability that you graduated times the probability that you're happily graduated. Happy given that you graduated. So the probability that you graduated is 85%. And the probability that you are happy and graduated is 90%. So you multiply those two probabilities together to get 0.765. All right, so now it's your turn. Let's copy down this tree. So we got graduated 85%, 90% happy, 10 not happy, 15% not graduated, 60% happy, 40% not happy. What is the probability that the student from the junior class 10 years ago in problem 4 did not graduate and is happy? So we're going to take the probability that they did not graduate and multiply it by the probability that they did not graduate given their, hold on, I'll do that backwards. They're happy and not graduated. So let's hunt down the probability that we did not graduate. And what's the probability that we're happy and not graduated? 0.60. Can we multiply those two probabilities together? We get 0.09.